Good morning all. How are you? Today we are going to continue with the topic and basically the atmosphere one, and that is general circulation of atmosphere. Now, if we talk about general circulation of atmosphere, so in previous sections what we saw that our atmosphere is having gases, then after it is divided into different layers and every layer is having a different characteristics and they are affecting our day-to-day life, or basically our day-to-day life is being affected directly or indirectly by them. Now after that we are going to see the circulation. As we know that the whole atmosphere is basically surrounding the earth from 0 to thousands of kilometers, means it's an envelope, and our atmosphere is not a closed system but rather it's an open system. So the whole atmosphere acts as a gigantic heat engine, means huge heat engine, because the energy coming from sun is basically in the form of, you can say, short wave radiation, and during daytime the earth's surface which is receiving the energy is radiating in night, and the gases which are present in our atmosphere, they are absorbing those gases and maintaining the earth's temperature, basically favorable for life. But in this situation, when the atmosphere is heated, a circulation starts, and due to the differential heating of land and sea, or you can say on different latitudes, the whole earth is divided in different temperature belts, wind belts, pressure belts and other patterns. So here in this topic we are going to see the temperature belts of earth, wind belts and pressure belts. So basically if we talk about temperature, so the temperature on earth is affected, or you can say is noticed in two patterns. One is globally, means you can say for whole earth, and one is, you can say, locally, means simply you can say the spatial or place wise. In simple terms you can say, means on local factor. This is on global factor and this is on local factor. Now we will see both of them one by one. So if we talk about the global pattern of distribution of temperature, so as we know and we have seen in latitudes and longitudes, the whole earth, or you can say the earth is tilted on its axis, or simply the earth is inclined. So due to the inclination of earth or the axial tiltation of earth, the sun rays which are coming to earth are not equal for whole earth. In some places the rays are vertical in nature, in some places they are oblique, and in some places they are horizontal. So basically we are going to see the example of two rays, vertical and oblique. Horizontal, they will become parallel to the ground. Now if I ask that the energy coming from sun for whole earth, is it equal or not? So basically the energy coming from sun for earth is equal, which is considered as solar constant. because the flux of energy which is coming is complete, or you can say equal. Suppose 10 unit of energy is coming from sun to earth. Now the angle of rays are going to determine the temperature of any place globally, or you can say latitudinally. How? Suppose the vertical rays are covering 1 meter square and the oblique rays are covering 2 meter square. Horizontal, the area will increase. Now the excessive effect of which rays are going to be there, and the most important thing, which will be heated fast and more and which is going to be heated less. So basically 10 unit of energy is heating up the 1 meter square and that 10 unit is heating up 2 meter square, means the area is being divided, or you can say shared in 2 meter. So vertical will heat up more, oblique will heat up medium, and the horizontal will heat up very less, or basically only the light will come, not the energy. Like the morning sun which is over the horizon, we get only the light but not the intensity. But as the sun starts moving over our head, the angle of the rays from horizontal start becoming vertical and the area go on decreasing and the amount of energy goes on increasing. And again afternoon, the sun start going over the horizon and the area increases and the amount of energy decreases. This is the first case. Second case, if we talk about the transparency of atmosphere, or basically the distance covered by the sun rays to reach the earth's surface. As we know that the shortest distance between any 2 points is the vertical or perpendicular, and as we move diagonally the distance goes on increasing. This means the vertical rays are only covering the distance of 1 atmosphere, means only 1 width of atmosphere, and when the rays will enter in the atmosphere, they are going to encounter clouds, dust particles, water vapor, all these. So when they will pass through the clouds and the other particles in the atmosphere, some of the energy is going to be absorbed, some will get reflected, some will get scattered. Means basically there will be some amount of energy loss. So suppose out of 10, 2 unit of energy is getting lost in the atmosphere. So ultimately the surface is receiving 8. Now in the oblique section, suppose the distance has become double. Now when the distance will become double, this means the amount of vapor presence, cloud, dust particle and other particulate matters will also become double. So the loss of energy will also be double, means instead of 2, the loss of energy will be 4. Means ultimately the surface is receiving only 6 unit. And let me tell you, when the sun rays are horizontal, means when the sun is over the horizon, the sun rays need to travel or cover the distance of 11 atmosphere, means 11 times more presence of cloud, dust particle, particulate matter, all the things, means 11 times more energy loss. So ultimately only the light will come, or the person will receive the light, not the energy. Third thing, that is the angle of incidence. And angle of incidence says that the vertical rays do the least reflection and the oblique rays do the maximum reflection. And what does reflection means? The bouncing back of energy or simply the amount of energy reflected by any surface without receiving. This means the vertical rays are receiving more and losing less, so ultimate the energy surplus will be there. Oblique, receiving and loss both are equal, so neither too hot nor too cold. And horizontal, only loss is there, no receiving. So basically, due to the three angles on which the sun rays are coming to earth, the whole earth is divided in different temperature belts. How? Let's see. Now you might be thinking, sir, you have written both 23.5 and 30 degree. So if you notice or remember, the sun migrates between 23.5 north to 23.5 south, Cancer to Capricorn. So technically, the sun rays are completely vertical till 23.5, and according to NCERT, they consider the exact one. But the meteorologist, means the climatologists or the scholars, they consider 30 degree and 60 degree. Why? As because sun rays are almost vertical till 30 degree on 80-85 degree angle. Like suppose take the example of Delhi, located on near about 28 degree north. The sun rays are not completely vertical. There is not a single zero shadow day, but the angle is near about 80-85. So basically the temperature in Delhi is high. So either you will get 23 or 30, 60 or 66.5. No need to get confused, and in exam anyone you can write down in the diagram till 30 degree north and south. The sun rays are vertical in nature, due to which it is considered as torrid zone, means hot zone, heat surplus zone, in which India lies, as we all know. Then after 30 to 60, the sun rays are neither vertical nor horizontal. They are slanting or oblique, due to which the income and expenditure is same, and it is considered as temperate zone. Okay, beyond 60, or you can say 66.5, the sun rays are almost horizontal in nature, means no energy surplus or balance, but rather these regions are energy deficit region, which are considered as frigid zone, which we name them as the polar areas or the frozen areas permanently. And if you notice, beyond 66.5, as we have seen and we know that there is 6 months of day, continuous day, and 6 months of continuous night. But instead of 6 months of continuous day, they are frozen, because if suppose if I am going to leave the sun over the horizon for the whole year, are you going to receive the energy? No. So this happens over here, and in this way, due to the angle of sun rays and basically due to tiltation of earth, the sun rays angle are changed and the whole earth is divided into 5 different temperature belts, 1 torrid, 2 temperate and 2 frigid. This is the latitudinal difference, means global distribution of temperature. But apart from global distribution of temperature, there are the local factors also which determine and you can say override the effect of latitudinal extent of the temperature of any place, and this is considered as the factors responsible for controlling the temperature of any place or local distribution of temperature. So let's see the factors which are responsible for the local distribution of temperature. Factors of local distribution of temperature. So as we saw, the first one is latitude, then after the second one is longitude, the third one, sorry, not the longitude, latitude, altitude, or you can say elevation or above mean sea level. Okay, then after distance, or before that I am giving you the technical term, continentality, which is also known as distance from sea. Then after the ocean currents and the prevailing winds. Then after vegetative cover, or you can say forest. Then after nature of slope, which is also known as slope aspect. So these are the few factors which locally govern the temperature of any place, despite of being located on different latitudes. Second thing, if we talk the major factors which are responsible for the local distribution of temperature, that is the top 5: latitude, altitude, distance from sea, ocean currents and prevailing winds, and the others are the subsidiary factors. So let's see one by one all of them. Latitude, we saw right now that how the latitudes are going to affect, or the latitudinal extent of any place is going to affect the temperature of any place. Now the altitude, elevation or the height above mean sea level is going to override the effect of latitudes. Now the question comes, how? Let's have a look. Suppose the places which are located between 30 north to 30 south are basically hot zone, we know, means the places will have very high temperature and especially 0 degree. Equator, as we know, throughout the year the temperature will be high. Okay, this means there will be no such place on equator or in torrid zone which will have less temperature. So it's wrong. If you remember the previous lecture of structure of atmosphere, what we saw in troposphere, that there is a normal lapse rate, means as we move up in the atmosphere vertically, the temperature decreases, means with the height the temperature will decrease. This means if a place is located on equator or between torrid zone but on a mountain, then the temperature will be not high but rather it will be low. Why? Because mountain means elevation, we are moving up in the atmosphere, and when we will move up in the atmosphere the temperature will decrease. This means even after sitting on equator, if the place is located on an elevated platform or a mountain, the temperature is going to be in minus. Like for example, Mount Kilimanjaro, located nearby equator, as you all know, highest peak of Africa, is having ice or snow, and many times the question has been asked that name the place on equator having ice or snow instead of being located in torrid zone, so it will be the Mount Kilimanjaro. So as you can see, the location of the place above mean sea level is basically overriding the effect of latitudinal extent of that place. Like for example, if in India we take the whole maximum of the India is located in torrid zone, we get ample of energy from sun during summer season. But if you notice and remember, during summer season we used to move towards mountain, Simla, Kullu, Manali, Oli, Ladakh. Why is it so? Hill stations. Because as we will move up, the temperature will become less. So this is the one effect, local effect, which is overriding the effect of latitudes. Now the distance from sea, which is considered as continentality, will also override the effect of latitude. How it is going to override the effect of latitude? Let's see. This is our India, as we all know. Okay. Now, this is sea and this is land. Okay. And these are the coastal regions. Now, if you notice, the diurnal range of temperature means the difference between the maximum and the minimum of the coastal places like Mumbai, Goa, Surat, Thiruvananthapuram, or Chennai or Visakhapatnam, that is very less. The maximum is 30-35, minimum is 28-25. Only 4-5 degree difference. Why is it so? This is as because of the land breeze and sea breeze. As we all know that there is a huge difference in the specific heat of land and sea. Land heat ups very fast and cools down very fast, and on the other hand the sea heat ups late and cools down late. So during daytime, if we see, we know land and sea. This is also land and sea. Now, when the sun will be there in the sky, means during daytime, the land is going to be heated rapidly. When the land will be heated, the air near to the land will also be heated, and it will expand and rise. When the air will rise, and due to heating of land during daytime, it will create a deficit of air that is considered as low pressure. Don't worry, the formation of pressure and what is low pressure, what is high pressure, how the pressures are formed on Earth's surface, we will see it, but after the temperature. First understand this. On the other hand, presently the sea is absorbing the energy, but it has not warmed up. So here the temperature is less and the air is sitting over the surface, creating high pressure. And the most important thing of air is that it used to move horizontally according to the pressure difference from high pressure to low pressure. Now when the air will move this side, automatically it is going to create a convectional cell, and this convectional cell, as it is breeze, it is considered as sea breeze during daytime. Now during night what will happen? The sun disappears. Now the land will cool down very fast, leading into high pressure, and the whole day sea has absorbed the energy. So now in night time it will become low pressure. Now the air, or you can say the wind, is going to move in opposite cell from land to sea, which is considered as land breeze. Now we are moving on to the coastal area. How the continentality, or you can say that the distance from sea is affecting the temperature of any place. So basically this part of India, is located below Tropic of Cancer, means 23.5 north. So they are experiencing the vertical sun rays more or less throughout the year. If we say exact, then twice a year. one in terms of moving north and one in terms of moving south. This means they are hot zones. But the places which are located nearby the coast are getting influenced by the land breeze and sea breeze. As the lands warms up, the wind or the breeze from the sea covers it, or as the sea warms up, the breeze from land compensate it. That's why the diurnal range of temperature difference between maximum and minimum is very less of the coastal areas. But on the other hand, if we see the areas which are located in the interior part of lands, or you can say the landlocked areas like Delhi, UP, Haryana, Punjab or Rajasthan, they are away from sea and basically from all side land is there. So during daytime when they are getting heated up, they will heat like a pan, or you can say sand, and the maximum will reach to 40, 45. And when the sun will disappear, means during night, they will cool down like ice, means the temperature will go to 15, 20. That's why the difference between maximum and minimum in the continental areas, or you can say the landlocked areas, is more in comparison to the coastal areas. And if you notice, this area are located beyond Tropic of Cancer, means they are never receiving the sun rays vertically, not even a single day, because sun is not going to migrate beyond Tropic of Cancer. So not a single place beyond Cancer and Capricorn will receive vertical sun rays or zero shadow day. So but instead of that also they are having more temperature than the areas which are located in the torrid zone. Why? Due to distance between land and sea. So latitudinal effect is being lower down by the effect of distance from land and sea. Now the fourth one, ocean currents. Now if we talk about the ocean currents, we know that there are two types of ocean currents, warm and cold. Okay, warm means they are having the warm property, cold means they are having the cold property. So when those water will reach to the coastal areas from where they are passing, they will affect the temperature of those places. Like, let me give you the example of few currents and places. When you will study the ocean currents, I am giving you the world map, don't worry. See, we know from equator the warm equatorial current moves and it moves into Gulf of Mexico. Before that it is considered as Skyne current. Then after near the coast of Florida, Florida current, and from here it used to move out as Gulf Stream. Now see, this Gulf Stream in the influence of westerlies become North Atlantic drift and the Norwegian current. Okay. Now, this North Atlantic drift and Norwegian current both are warm in nature, and if you notice, they are moving in the temperate latitude, means the temperature will be less. Now, during winter season, the temperature will become more or less, and basically the coast of Europe must get freeze down, but you know, they remain open throughout the year, and that's why the Europeans were able to colonize the whole world. How? Because when the warm North Atlantic drift and Norwegian current move to the northern coast of Europe, what they do, they turn the chilled water in milder water, which prevent the water present in the temperate latitudes from freezing, and that's why the ports of Europe, especially the northern part, are open throughout the year, means especially during winter season. Now you can notice that the latitudinal extent again is being, you can say, lower down, the effect of latitudinal location, and the ocean currents are determining the temperature of those local places. Another example if we give, the cold Labrador current, when it comes from the Labrador Sea on the eastern coast of Canada, the eastern coast of Canada is frozen and the northeastern during winter season, but the North Pacific drift or current and the Alaska current, they are warm in nature, so they keep the western coast of Canada and southern Alaska open throughout the year. If we see the example of Japan, one is Oyashio current and one is Kuroshio current. Kuroshio is warm and Oyashio is cold. So when the Oyashio enters in Japan, it moves towards the western coast of Japan, and during winter season they are frozen. But simultaneously, due to warm Kuroshio, the eastern coast of Japan are open during winter season also. This means a single place, and basically we know Japan is an island, Honshu, Hokkaido, Kyushu and Shikoku. So basically island means a small patch of land in the oceans. So that the coast of particular island also is being affected. One part is open throughout the year, one part is being frozen during winter season due to the presence of ocean currents, and the location is same latitude. So the latitude effect is again neglected or overlooked due to the presence of ocean currents. Now the prevailing winds. Same cases of prevailing winds means the permanent winds. As you will come to study that westerlies, polar easterlies. Westerlies are warm in nature and polar easterlies are cold in nature, means the Siberian winds. Now when the westerlies from the lower latitude will move towards the higher latitude, they will carry the property of hotness, warmth, and they will make the chilled weather milder. But when the cold, chilled, dry Siberian or the polar winds will move out and come in the tropics or the lower latitude, they will carry the chilledness and they will decrease the temperature. And if you have noticed, when this used to happen, even the northern part of USA also get frozen, like the Niagara Fall, when the polar chilled winds enter more inside, and that was considered as the breaking of polar vortex. Now the question comes, what is polar vortex, sir? Don't worry, we will see that also. But first, understand the circulation. So you understood how the prevailing winds are also going to affect the temperature of any place instead of being located in lower or the higher latitudes. Then after, if we talk about the vegetative cover, vegetative cover means the forest, and forest means the shadow. So the places which are going to have, or basically the places which are having forest, the temperature of those places will be very less. But the places which are not having forest cover, the temperature will be high. Like if you notice, or I am making you remember, during summer season when we go to our villages or grandmother's or grandfather's house or maternal's house, what we used to do in our childhood? We used to play in the orchards of mango. We used to sit in the garden below the tree. Why? Or in the shade of the tree? Because the area which is being covered by the trees or those which are located in forests, those places are much cooler than the places which are open or having no vegetative cover. Means more the forest, less the temperature. Less the forest, more the temperature. Means if the places are located in torrid but more vegetative cover, temperature will be less, the moisture will be more. But if you are not in tropics also, but if no vegetative cover is there, the temperature will be high. And the last aspect is the nature of slope, or basically the sun facing slope. The question comes, which slope of the northern hemisphere mountains are going to face the sun and have more vegetative cover? So basically, the northern slopes, the southern slopes of northern hemisphere mountains will face the sun rays directly, and the northern slopes will not receive the sun rays. So the places which will receive the sun rays, basically the slopes, their temperature will become milder instead of chilled, because as we know that when we will move to the mountains, the temperature is going to decrease. But if there will be the sun rays, the temperature will decrease with very less amount. But if that place is not going to receive the sun rays, it will be more chilled enough. That's why the southern slope of Himalayas are having more vegetative cover, and the northern slope of Himalayas towards Tibet are basically very less vegetative cover and more chilled in comparison to the southern slope. Now in southern hemisphere, if we say the sun is going to shine like this, so the northern slope of southern hemisphere will receive the sun rays directly, and the southern slopes are not able to receive. This means the northern slopes of southern hemisphere mountains will have more temperature and more vegetative cover. On the other hand, the southern slope of southern hemisphere mountains will have very less temperature and very less vegetative cover. Because in the previous lecture also what we saw, that the temperature determines the germination of life and the greenhouse effect. So if the places will be very cold, then it will be harsh for life and its survival. But if the place will be milder, temperature will be good, then basically that will be a favorable conditions. So as you saw that the temperature of any place is not only being completely governed by latitude, but rather the presence of other aspects also, like the elevation from mean sea level or the distance from sea, ocean currents or prevailing winds or vegetative cover or the nature of slope are also governing the temperature of those places. And in this way, the whole earth is having a different temperature on different places. But globally is different. Latitude, where other aspects are neglected, because we are seeing collectively the whole earth in respect to the sun rays which are coming to earth, complete. But when we will go precisely, then instead of latitude, we have to see the other aspects also which are governing the temperature of those places. Now, as we understood about the temperatures, now we are going to move towards the creation of pressures on earth, and then after we will see the wind and finally the general circulation of atmosphere. So in the next class we will move on to the pressure creation and the wind belts of earth. Till then, thank you. Have a nice day.